Hello and good evening, everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to GATE Conqueror channel. And I welcome you all to my class of EM Wave Propagation. We're starting a new chapter today, EM Wave Propagation. We're done with module 1. It is static and time varying fields. We are moving into the wave propagation. Good evening. Sorry, dear. Just confirm the video and audio once. Well, fine. Good evening, Sneha. Good evening, Anil. Surendra, good evening. Bhaskar, good evening. Good evening, everyone. So ask everyone to join very soon, dear. In EM wave propagation concept, we'll start and with wave propagation in free space. In EM wave propagation, lecture number 1. Before we move in, let me introduce myself. I am GC Reddy. Secured AAR 1931. I work as motivational speaker for the past 12 years, pan India. An expert in field theory and communications. Please confirm the video and audio once, dear. Is audio, video, everything clear? As you know, this is the official Telegram channel for our GATE Conqueror YouTube channel. This is the official Telegram channel, dear. Just make a note of this particular link. You can join us on Telegram and have a personal level assistance from all the GATE Conqueror faculty. So in EMFT, we're already done with Maxwell Equations, for static fields, we're done with Maxwell Equations for time varying fields, capacitors and inductors, Poisson's and Laplace equations, and boundary conditions. A separate playlist of 40 videos is already uploaded in GATE Conqueror channel. You can just go through them. Complete analysis of EMF is done there. Surojit Mitra. Hi, dear. Okay. You can go through these 40 videos. A complete analysis is given here. Any doubts in EMF? At any point of time, you can ask us. You can ask me in person. I am ready to help you. Is that clear? Yes, Surajit, any doubt here? Fine. Any doubt you can ask here. Now we are moving into EM wave propagation concept, which is an extension of Maxwell equations for time varying fields. We are into wave propagation. So let me give the synopsis of what we are going to study in this module of EM wave propagation. In EM wave propagation, we will discuss on how EM waves propagate in free space. The topic of EM wave propagation in free space. So I try to analyze how an EM wave will propagate in free space in this particular topic. Then we'll see the EM wave propagation in materials where conductivity is not equal to 0. In free space, how much is conductivity? Anyone? Then we'll see EM wave propagation in good conductors. Then we'll see EM wave propagation in good dielectrics. And we'll see EM wave propagation in perfect dielectrics. Can anyone tell me what is the conductivity value in free space? Zero. Good. Good, Bhaskar. Karna, good. Okay. Sigma is 0 here. With this, we'll complete EM wave propagation through different mediums. Then we'll start the power associated with the given wave by using pointing theorem. Then we'll see when a wave propagates, it will undergo any one of the polarization. So we'll see what is polarization, types of polarization, the concept of wave polarization. We'll also see reflection and refraction of plane waves. As a part of this, we'll discuss important concepts like Brewster angle, total internal reflection, and critical angle. So dear, this is the index of what you are going to study in module 2. EM wave propagation. So basically, I can say that this particular module is about understanding how wave propagates through different mediums and what is the power associated, polarization associated with a given wave, and what happens when the wave is incident on a given medium, how much amount of the wave is getting reflected and how much amount is getting refracted. We calculate the reflection coefficient and the transmission coefficient, and also analyze some important terms like Brewster angle, critical angle, and total internal reflection. This is what we do. Very important module, exclusively for ECE people, carries around 3 to 4 marks. Very, very important for GATE. Of course, wherever EMTL syllabus is there, in all those examinations, it is very important. Especially for GATE, we have 3 to 4 marks from this module itself. Now my question is, as you know that in this module we try to analyze EM wave propagation in different mediums. The question is very simple. Are we having any equation for a given wave? Had we already derived any equation for the given wave? Is the wave equation derived already? We have derived Maxwell equations. Have we derived the wave equation? Wave equation will tell you how an EM wave will propagate. Bhaskar, we are not derived wave equation. We are derived Maxwell equations. Listen carefully. We are derived Maxwell equations for static fields. How many Maxwell equations are there for static fields? How many Maxwell equations are there for static fields? How many Maxwell equations are there for static fields? Those are, yes, Bhaskar, those are Maxwell equations for time varying fields, dear. Wave equation is not derived yet. I'll tell you the difference. Just listen carefully how beautifully we can link the subject you see. Yes, dear. How many Maxwell equations were derived for static fields? How many dear? We derived 4 Maxwell equations for static fields. Am I right? What is the first Maxwell equation? Yeah. What is the first Maxwell equation? Bhaskar, Surendra, Anil, Sneha, anyone? What is the first Maxwell equation? Equation number 1 is from Gauss Law. Closed surface integral of d dot ds is volume integral of rho v dv. Differential form del dot d is equal to rho v. Source Gauss law for electrostatic fields. Am I right? What is the second equation? Closed loop integral of E dot dl is 0. Closed loop integral of E dot dl is 0. Differential form del cross E is equal to 0. Source conservative property of electric field or electrostatic field. Third one, closed loop integral of h dot dl is equal to surface integral of j dot ds. Differential form del cross h is equal to j. Source Ampere's law. Okay. What is the fourth equation, dear? Anyone? Fourth equation, closed surface integral of B dot ds is 0. Integral form, differential form del dot B is 0. Source non-existence of magnetic monopole. Also called as Gauss law for magnetostatic fields. So these are Maxwell equations for static fields. Clear? Now, if you take the first law, just the Gauss Law, according to Gauss Law, the flux cut by any closed surface is equal to charge enclosed by the surface. This is called Gauss Law in true form. Listen carefully, dear. This Maxwell equations recap is very, very important when you are starting wave propagation. Where psi E is the electric flux related to electric flux density as electric flux per unit surface area, unit coulomb per meter square. Electric flux or electric charge is given in coulombs. If you consider a small surface area ds, the flux associated with it is d psi E. The flux density is d psi E by ds. Implies d psi E is equal to d into ds. This is called scalar notation. This is called scalar notation. In vector notation, write as d dot ds, dot product of any two vectors, is a scalar quantity. Here d and ds are both vectors. The dot product of them is a scalar, which is electric flux. Implies d psi E is equal to d dot ds, implies psi E is equal to integral on both sides closed surface integral of d dot ds. You got this flux here. Now, how charge and charge density are related? How charge and charge density are related? If you consider a line, it contains line charge density. It is total charge in the line by total length. If you consider a small length, the charge associated with it is dq. It is dq by dl, unit coulomb per meter. From this dq is rho l into dl. From this q is line integral of rho l dl. Similarly, this is when you are considering a line of length L carrying uniform line charge density rho L. Total charge associated is Q. Total length is L. Similarly, if you consider a surface carrying total charge Q, surface area S, if you consider a small surface area ds, charge associated with it is dq. Here also, when you consider small length dl, charge associated with it is dq. Therefore, dq is rho s ds. Similarly, q is surface integral of rho s ds, relation between charge and charge density. Similarly, if you consider a volume carrying total charge Q, total volume V, volume charge density is total charge by total volume coulomb per meter cube. Here unit is coulomb per meter square. In this, if we consider a small volume dV, the charge associated with it is dq. It is dq by dV. dq is rho v dV. Q is volume integral of rho v dV. Clear? Therefore, how is Q related to these charge densities or distributed charge densities or distributed charges? Q is line integral of rho L dl, surface integral of rho s ds, volume integral of rho v dv. When you take the generalized case, we take in terms of volume. So charge enclosed is volume integral of rho v dV. Equating these two equations, psi is equal to charge enclosed. Closed surface integral of d dot ds is volume integral of rho v dV. This is called integral form of Maxwell first equation. Clear? Now this is in closed surface and this is in volume. If you want to simplify this, we apply divergence theorem. What is divergence theorem? According to divergence theorem, closed surface integral of A dot ds is volume integral of del dot A dV. It relates closed surface to volume. It relates what, dear? Closed surface to volume. Sorry. Is the video clear now? Fine. Okay. Is that clear now? Okay. I was getting severe cough. For a second, I thought to hide it. I forgot to show again. Okay. You must be telling me, okay, when this thing happens, as I'm having cold. You understand, okay? So, fine. Closed surface integral of A dot ds is volume integral of del dot A dV. What is this doing? It is relating closed surface to volume. It is relating closed surface to volume. This is the closed surface. It relates the closed surface to volume. If A is any energy associated with this closed surface, it relates that energy to this volume. For example, A is some light energy. The amount of light that is kept on these surfaces, the amount of A, that is light, that is kept on this closed surface, is equal to the amount of light that is spreading in this volume. Divergence. Spread. Similarly, am I right? It's natural. The more amount of light you keep on these walls, the more amount of light will spread in this volume. Am I right? As simple as that. So it relates closed surface to volume. This is how you can try to interpret divergence theorem. So here, closed surface integral of d dot ds is volume integral of del dot d dv is equal to volume integral of rho v dv. This implies del dot d is equal to rho v. This is called differential form of Maxwell first equation. This is Gauss law for electrostatics. Clear, everyone? Okay, now conservative property of electric field. Work done is related to force and displacement as force into displacement is work done. Work done is a scalar quantity. Force and displacements are vectors. Therefore, dot product will be ideally suitable here. Dot product of any two vectors is a scalar quantity. What is this work done? As you know, force into displacement. Here force is electric force, that is force acting on charge particle Q in the presence of electric field E. Substituting Q, force acting on charge particle Q in the presence of electric field E. And what is work done? Work done is in moving this charge Q present in electric field E by value of L. That is work done. If I consider small work done dW is Q into E dot dl. From this work done is Q into integral of E dot dl. If I take an assumption that external agent is doing the work, the work done will become negative. W is minus Q into integral of E dot dl taken over a path length of L. From this electric potential V is work done per unit charge minus integral of E dot dl. Therefore, the relation between V and E is V is minus integral of E dot dl. This for path of length L. If this path is having two limits A and B, then you get VAB minus integral of A to B E dot dl. VAB is given as VA minus VB moving from B to A. Once I write B to A, when I take B to A, I'll take the limits minus B, integral minus B to A, initial point to final point. Is minus integral A to B, minus integral B to A, E dot dl. Simply if I want potential between these 2 points, it is VAB, it is VA minus VB. Moving from B to A. If I want potential between A and C, VAC, VA minus VC. A and D, VAD, VA minus VD. A and A, VA minus VA, 0. That means what? When I am closing the loop, how much potential you are getting there? When I close the loop, you get 0 potential. Is this clear? Yes, let me know. Is that clear? everyone. Yeah, fine. Okay. Diagram. 1 second. This one dear. See here. VAB. VA minus VB. VAB means moving from B to A. Minus integral initial point B to A E dot dl. VAB means moving from B to A. These are 2 points. This is A, this is B. Work done in moving the charge from B to A, in which the potential calculated is VAB, which is VA minus VB. Clear? Now I am removing this point, Bhaskar. I am removing this point and having this point at C. Now you tell me how much is VAC, Bhaskar? VA minus VC. Clear? I am removing this point. Having here. Now you tell me how much is VAD? VA minus VD. Clear? Yes. Now yes, 0. VA minus VA 0. Clear? So, what is trying to tell here? When I close the loop L, the potential will become 0. 0 is equal to minus closed loop integral of E dot dl. Implies closed loop integral of E dot dl is equal to 0. Integral form of Maxwell second equation. Clear? Just a second here. Just a second. Okay. See, when I forget to on the video again, please remind me, okay? That in this class, other time I forgot, and after 7-8 minutes I realized. Okay. Very good, Bhaskar. Very good, very good. So next, if you apply Stokes theorem on this, what is Stokes theorem? Stokes theorem relates closed loop to surface. Closed loop integral of A dot dl is surface integral of del cross A dot ds. How to understand this? If you take a closed loop, A is the energy source, let it be light energy again. The amount of light that is kept on the loop is equal to the amount of light that is circulated, del cross A, curl, oriented in this particular surface area enclosed by the loop. This surface area is ds. This surface area, small area is ds. Complete area is s. Amount of light that is circulated in this area is equal to the amount of light that you kept on the rope that is encircling the area. Clear? That is Stokes theorem, which relates closed loop and surface. Now if you apply the Stokes theorem here, closed loop integral of del cross E dot dl is surface integral of del cross E dot ds is 0. Implies del cross E is equal to 0. Curl of E is 0. Implies static electric field is irrotational. It moves in straight line. Clear? Yes. Correct, Bhaskar, correct. Okay. Clear? So that's the Maxwell second equation. Closed loop integral of E dot dl is 0. That is del cross E is equal to 0. Static electric field is conservative in nature. E is irrotational. E is conservative in nature. Next is Maxwell third equation. Which is from Ampere's law. According to Ampere's law, the line integral of tangential component of magnetic field around a closed loop L is equal to the current enclosed by the loop. Mathematically, I can say circulation of H is equal to current enclosed. where I enclosed related to current density as current and current density are related as current density is current per unit surface area given ampere per meter square. If you consider small surface area ds, current associated with it is di, J is di by ds, J is di by ds, implies di is equal to J into ds, scalar notation, vector notation, J dot ds, I is surface integral of J dot ds, relation between current and current density. This is for open surface. I is closed surface integral of J dot ds. This is for closed surface. Here what shall we take, closed surface or open surface, anyone? You can't say divergence, it is dot product. You can use the word Bhaskar divergence only when it is operated on del. Yes, Bhaskar. If you are asking why dot product, I can tell you. Because what is resultant? H and dl, what is resultant? Resultant is current. Current is scalar, no? First thing, Bhaskar, you should not use word divergence. Divergence is used only when you use dot product using del. Del dot something. Yes, dot product is correct. Dot product we are using because H is vector, dl is vector, current is scalar. Is it clear? If a closed loop integral of H dot dl is equal to, now you tell me, closed loop, closed surface or open surface? Closed line always have open surface. Wonderful. This is having a closed loop here, therefore open surface only. Wonderful. Super. So closed loop integral of H dot dl is equal to surface integral of J dot ds. It's called integral form of Maxwell third equation. Next. Now if you want to convert this into surface, apply Stokes theorem. Applying Stokes theorem, closed loop integral of H dot dl is surface integral of del cross H dot ds is surface integral of J dot ds. Implies del cross H is equal to J. This is differential form or point form of Maxwell's third equation indicates that unlike static electric field, static magnetic field is not irrotational. It is a rotational field. Yes, everyone knows that magnetic field is a rotational field. It is also telling the same thing. Clear? Correct, Bhaskar. Okay. So this completes the third equation, Ampere's law. Now the fourth equation, non-existence of magnetic monopole. Non-existence of magnetic monopole. Gauss law for magnetic fields. Non-existence of magnetic monopole. It states that in a magnet, a monopole does not exist. Always, both North Pole and South Pole. You'll have both the poles, North Pole and South Pole. A single pole will not exist. And now the magnetic flux lines move from North Pole and they end on South Pole. They start on North Pole and they end on South Pole. There will be uniform magnetic flux moving from North Pole to South Pole. And outside the magnet, the flux lines will move from North Pole to South Pole. Inside the magnet, they move from South Pole to North Pole, forming the closed loops. For magnetic flux lines always form the closed loops. You know, magnetic flux density is related to magnetic flux as magnetic flux per unit surface area. Magnetic flux is given in Weber area meter square. The unit is Weber per meter square or Tesla, after the great genius Nikola Tesla. Am I right? Weber per meter square or Tesla. If you consider small surface area ds, flux associated is d psi m. D psi m is B into ds. Scalar notation, vector notation. D psi m is B dot ds. Psi m is surface integral of B dot ds. There is a relation between magnetic flux and magnetic flux density. And if you consider here, what is the net flux generated by this magnet here? Anyone? What is the net flux generated here? What is the net flux generated? This fellow is giving out psi m. It is taking in psi m. The net flux generated is 0. Let's close the surface integral of B dot ds is 0. It's called integral form of Maxwell fourth equation for static fields. Applying divergence on LHS, volume integral of del dot B is 0, implies del dot B is equal to 0. Divergence of magnetic flux density is 0. Therefore, B is divergence-less. B is divergence-less vector. This is called differential form or point form of Maxwell fourth equation. Clear? B is called as solenoidal vector. This forms the fourth equation. These are Maxwell equations for static fields. In this, how many equations we need to change? Anyone? In this, how many equations we need to change? In time varying fields, how many equations will change? Out of these four equations, these dot product equations will not be changed. They will be as it is. These two equations will be changed. Change of this equation is given by Faraday's law. And this equation change is given by Maxwell contribution. also called as inconsistency of Ampere's law. So when you are trying to move from static fields to time varying fields, only two equations will change, not all the four. Therefore, when you are trying to tabulate Maxwell equations for time varying fields, when you formulate Maxwell equations for time varying fields, dot product equations will not change. Only cross product equations will change. Is it clear? Equation number integral form, differential form or point form, and source. First equation, no change. Closed surface integral of d dot ds is volume integral of rho v dv. Differential form, del dot d is equal to rho v. Source, Gauss law for electric fields. Second equation, you are going to change. Second equation we are going to change using Faraday's law. Third equation you are going to change using Maxwell contribution. Inconsistency of Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Del dot B is 0. B is divergenceless field or solenoidal field. From non-existence of magnetic monopole or Gauss law for magnetic fields. Clear? These two we need to derive, Faraday's law and Maxwell contribution. So far is it clear? Start up with Faraday's law. According to Faraday's law, induced EMF in a closed path is equal to the rate of change of flux linkage. Later on, scientist named Heinrich Friedrich Emil Lenz stated that the induced EMF always opposes the flux produced it, and introduced a negative sign here, which became the complete Faraday's law. VEMF here is closed loop integral of E dot dl is equal to lambda is flux linkage n times Im, n into d psi m by dt. If you see here carefully, I am trying to keep the closed loop, but this value is not becoming zero. Why? Because only static electric field is conservative. Only for static electric field, only static electric field is conservative. Only for static electric field del cross E is 0. Only static electric field will move in straight line, but not time varying electric field. Only for static electric field closed loop integral of E dot dl is 0, because del cross E is 0, because E is conservative, because static electric field will move in straight line, but not for time varying electric field. Therefore, you need not make it 0. Here lambda is the flux linkage, n is the number of turns. For straight conductor, n is 1, substituting n is 1. Closed loop integral of E dot dl is minus d psi m by dt. Psi m, magnetic flux related to magnetic flux density, as psi m is surface integral of B dot ds. Closed loop integral of E dot dl is minus d by dt of surface integral of B dot ds, implies closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. This is called integral form of Maxwell's third equation for time varying fields. In terms of order, it is number 2. Second equation for time varying fields. This is integral form. Closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. This is the integral form Maxwell equation. It is the second Maxwell equation for time varying fields. Sure, 100%. Physical phenomena. We'll explain to you. Don't worry. Applying Stokes theorem, surface integral of del cross E dot ds, closed loop integral of E dot dl is surface integral of del cross E dot ds is equal to surface integral of minus dou b by dou t dot ds, implies del cross E is equal to minus dou b by dou t. This is differential form or point form of Maxwell's second equation for time varying fields. Now, as they're asking the physical phenomena, listen carefully dear. How to understand the physical phenomena is according to Oersted, there is a link between current and magnetic field. What it says is, whenever a current is flowing in a given circuit, there will be a static magnetic field around it. This long back in 1820, Oersted has proposed this law that wherever there is a DC current, there will be static magnetic field. So many of you people know Faraday's law. But you need to understand from Faraday's principle. You know what is Faraday's principle? According to Oersted, whenever there is a DC current, in a given circuit, there will be magnetic field associated with this current. But the reverse is not true. That means what? A DC current can produce static magnetic field within a closed path. But a static magnetic field within a closed path cannot produce current. Listen carefully. DC current can produce static magnetic field within a closed path. But vice versa is not true. That means static magnetic field cannot produce current. But rather, time varying magnetic field will induce an voltage named as EMF, which is indeed responsible for the flow of current. Such induced EMF, as stated here, will be equal to rate of change of flux linkage. From here, we write Faraday's law. We start from this point, but students should understand from this point. A DC current can produce static magnetic field. But vice versa is not true. But a time varying magnetic field will induce an EMF within a closed path, which will be indeed responsible for the flow of current. Such induced EMF will be equal to rate of change of flux linkage. From this you got Faraday's law. First thing, is that clear? Everyone, is that clear? Very good. Now, the second phenomena is this equation. This equation says that del cross E is minus dou B by dou T. You can see that there is a relation between electric field and magnetic field, which was not available in static fields. If you see static fields, they are all independent. Electric field and magnetic field are not dependent on each other. If you have this independency, in time varying fields, wave will not generate. Wave will not be generated. Therefore, in time varying fields, there must be interdependency between the fields. Here you can see del cross E, curl of E, orientation of, or you can say spatial. Why spatial? For example, you take del in Cartesian coordinate system. Dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. Spatial orientation. Spatial orientation of electric field is resulting in what? Time varying magnetic field. There is a specific link between orientation of electric field and the time varying magnetic field. This interdependency is must if it wants to be a part of a wave. Let me talk about wave later on, because that's the main topic, wave propagation. I want to come into the concept of wave, which you will achieve from time varying fields. In time varying fields, the one main equation is this. One more equation once I derive, you will understand the physical phenomena of a wave. Then we will move into module 2. To understand time varying fields, you should know static fields. So, in detail, I explained static fields so that those who had missed the previous classes also can understand very clearly wave propagation without any doubt. So, we had explained all the static field theory concept, that is Maxwell Equations for static fields here, and we had modified conservative property of electric field, where we got Faraday's law. We have done the physical interpretation of the Faraday's law. Closed loop integral of E dot dl is surface integral of minus dou B by dou T dot ds. Differential form del cross E is equal to minus dou B by dou T. Spatial orientation of electric field depends on time varying magnetic field. Clear? Okay, now inconsistency. Inconsistency of Ampere's law. Inconsistency of Ampere's law. Called as Maxwell contribution. This is the main contribution of Maxwell. That's the reason why all the equations are after his name, named as Maxwell Equations. What was his contribution? Listen carefully. What is Ampere's law? Del cross H is equal to J. What is J there? Conduction current density, sigma E. It depends on conductivity of the material. According to Ampere, current can only flow when there is a conductor. Without a conductor, current cannot flow. And most of the scientists has done their experiments basing on Ampere's law. And they have got so many patents also after this. So according to Ampere, current can only flow when there is a conductor. At this time, around 1850, are you all listening carefully? Everyone. Yes. So what Ampere told is, only when there is a conductor, current will flow. Is it true? What Ampere is telling you is, current will flow only when there is a conductor. Without conductor, current cannot flow. So for the flow of current, conductor is required. This is what Ampere has told you. But in 1850s, one scientist named Maxwell, he said that for the flow of current, conductor is not required. Rather, current can flow in air. He said that current can flow in air. Ampere is wrong. Current can flow in air. Current can fly in air. Such current will result in a time varying field. Poor Ampere do not know about time varying field. He said that Ampere is inconsistent. He don't know that there is a time varying field. So he is assuming that current, for flow of current, conductor is required. He has written a big thesis on this and submitted to panel headed by Ampere. Got it? It is like you are submitting an assignment stating that it is like you are submitting an assignment stating that whatever your faculty has taught in your class is false, and you are submitting that assignment to your faculty, what happens? You tell me. Yes, anyone? What happens? The faculty has given an assignment, you had submitted the assignment. In the answer, you are stating that, you have written an answer stating that whatever he has taught in the class is wrong. He will reject that, am I right? Will you accept your assignment? He will reject the assignment, am I right? Am I correct? That is what has happened to him. Maxwell stated that conductor is not required for the flow of current. Current can fly in air. Such current is called displacement current, which will lead to time varying field. And ampere is inconsistent. Ampere don't know about that. And submitted his thesis to Ampere. This is a real thing happened. Ampere rejected that. It was not fault of Ampere. I can't say that it is complete fault of Ampere also. I can say Ampere was ignorant. Ampere was ignorant. Because even to be clear, Ampere also don't know that there is a time varying field by that time. By 1850, Ampere also don't know. By 1850, really Ampere also don't know that there is a time varying field existing. So naturally you will reject them, right? Is it clear? Everyone, is it clear? So he rejected. You need to understand. It is in 1850. This is happening in 1850. Today it is very easy. Today it is very easy for me to convince you people that the current can flow in air or it can fly in air. Because today you are having cell phone where you are getting the signal as EM waves. The current is flying in air. It is easy to convince. But this was way back in 1850. A scientist saying that the current can fly in air, and nobody in this world know that, including Ampere. Unfortunately, he must submit that thesis to Ampere itself. Even Ampere do not know. His panel members don't know. All his panel members are the fellow scientists who had done most of their research basing on Ampere's law only. So they all rejected. You know what is the problem with Maxwell? Maxwell was 50 years ahead of his generation, at least. When you are ahead of generation, People cannot understand because you are thinking 50 years beyond what others can think. So naturally, no one will understand. That was the greatness of Maxwell actually. His thesis was rejected. No one understood what he actually wanted to say. Later in 1900, after around 50 years after this incident has happened, one more very giant big scientist, Hertz, demonstrated electromagnetic waves, and he told that these waves, the Hertz scientist after whom the unit of frequency is given, he said that these waves behave exactly as Maxwell told. There is nothing greatness in me now. These are behaving just exactly as Maxwell told. That was really the greatness of Hertz also. We are very lucky that in those times Faraday's law was modified by Lenz for the betterment. Ampere's law was modified by Maxwell, approved by Hertz. See, that was the greatness of those scientists those days. Today we think on our own lines for our own benefit. We do not want any other's name to be credited. Even if you write a small assignment, we make sure that that is ours. We don't give credit to anyone, am I right? But those people never thought of themselves, their credit. They always thought as a true engineer. A true engineer will always think like how to make this world a beautiful place to live. Those people have done that actually. That's the reason why today we got some wonderful theories where science has got developed so far because of their contributions. Got it, everyone? So that's the reason why actually we call all the equation names as Maxwell equations, because around 1879 Maxwell died. No one understood his theorem, his contribution, and Maxwell died. Around 21 years after his death, Hertz told to this world that Maxwell was correct. As a token of gratitude, we call today all these equations after the name of Maxwell. Got it now? Everyone, is that clear? So what Maxwell has done is, he said that Ampere's law is inconsistent. To show that Ampere's law is inconsistent, he had done divergence on both sides. And according to vector identity, Nara sir, good. Thank you. Ashrit, yes. Bhaskar, very good. Divergence of curl of any vector is 0. What Maxwell has done is, he had done divergence on both sides. Then according to vector identity, divergence of curl of any vector must be 0. So you got 0 is equal to del dot j. There is a small ambiguity here. What is that ambiguity? This ambiguity, you'll get this ambiguity from conservative property of charge. Conservative property of charge. You know what is conservative property of charge? Ashrit, how are you? What is conservative property of charge? According to conservative property of charge, the rate of decrease of charge within a closed volume, rate of change means dq in by dt. Rate of decrease means minus dq in by dt is equal to net outgoing current. This is called conservative property of charge. According to conservative property of charge, the rate of decrease of charge within a closed volume is equal to net outgoing current. It is a natural phenomena. Why I am calling it as a natural phenomena? The rate of decrease of charge within a closed volume is equal to net outgoing current. Let me take an example of phone. Cell phone. If you use your cell phone continuously, what happens? If you use your cell phone continuously, what happens? The charge will decrease. Am I right? The charge will decrease. In this cell phone, there is a battery, which is a volume, which is holding charge. The rate of decrease of charge within this volume is equal to how much? The amount of current that is going to this motherboard of this phone. If you use more, the charge will reduce very fastly. That means what? It's a natural phenomena. The rate of decrease of charge within a closed volume is equal to net outgoing current. It's called conservative property of charge. It cannot be wrong. If you consider a volume, how Q is related to volume, I told you in the starting of this class. Q is volume integral of rho v dv. I out. Current and current density, how they are related? This is minus volume integral of dou rho v by dou t of dv is equal to. How current is related to current density now? Shall I take closed surface or open surface? Anyone tell me? Shall I take closed surface or open surface? Shall we take closed surface or open surface? Closed or open? LHS is volume bounded by closed surface. Applying divergence on this, closed surface integral of j dot ds is volume integral of del dot j dv, divergence theorem, is equal to volume integral of minus dou rho v by dou t of dv. Removing the volume integral on both sides. What is del dot j? Del dot j is equal to minus dou rho v by dou t. This is called conservative property of charge. And the equation name is called as continuity equation. Continuity equation is from the principle of conservative property of charge. And it's a natural phenomena. It cannot go wrong. So I can say continuity equation cannot be wrong. Am I right? And according to continuity equation, del dot J is equal to minus dou rho V by dou T. Clear everyone? But now you got here del dot J is 0. But you know del dot J is minus dou rho V by dou T, which is continuity equation. This cannot be wrong. Therefore, there must be some change in this only. In this equation, we need to have some change. That is what Maxwell has proposed. That there must be some change here. There is some problem with this equation. He said that Ampere is only considering static field. That's why you are getting this problem. But there is time varying field which will contribute for displacement current density called JD. If you consider this, everything will be okay. And he had modified the equation. Del cross H is equal to J to del cross H is equal to J plus JD. You see what you have done? He had done divergence on both sides again. After modifying, del dot del cross H is equal to del dot of J plus JD, where J is conduction current density, JD is displacement current density. According to vector identity, del dot del cross H is 0. 0 is del dot J plus del dot JD. Implies del dot JD is minus del dot J. But as you know, it must satisfy continuity equation also. Very good, Bhaskar. According to continuity equation, del dot J is minus dou rho V by dou T. Substitute. Del dot JD is minus of minus plus dou rho V by dou T. Implies del dot JD is dou by dou T of, from Gauss Law, del dot D is equal to rho V of del dot D. Implies del dot JD is del dot dou D by dou T. Implies JD, displacement current density, is dou D by dou T. That means what? If I add JD, which is equal to dou D by dou T, it will satisfy vector identity and it will satisfy continuity equation. Both. That's why the modified equation is del cross H is equal to J plus JD, where J is conduction current density, sigma E, JD is dou D by dou T, displacement current density. At any point, the current is sum of conduction current density and displacement current density. For example, if you consider in a conductor, displacement current density in a conductor, displacement current density is 0. Only current that you have is conduction current density. In free space, conduction current density is 0, no conductor, only current is displacement current. That's why if you want to find at any point, current is the sum of conduction current and displacement current. Clear now? So what is it? Closed loop integral of H dot dl is surface integral of J plus JD dot ds. J is sigma E, JD is dou D by dou T. Implies del cross H is J plus JD. J is sigma E, JD is dou D by dou T. This completes Maxwell equations for time varying fields. Now, in this, these two equations are the modified equations. Put together, you'll get wave equation. This wave equation will tell you the behavior of a wave. This wave equation I'll tell you, Bhaskar, don't worry. These two equations combined, you'll get wave equation. See how closely module 2 is related to module 1. In module 1, we had stopped here. Now, I'll combine these two equations, you'll get a wave equation. Wave equation is also called as Helmholtz equation. When you add these two equations, you get Helmholtz equation. Helmholtz equation will give you wave equation, which will tell you how the wave is propagating. The question Bhaskar was asking is, in free space you will have displacement current. In capacitor also you will have displacement current. What is the difference? I'll tell you. Indeed, Maxwell has used this example of capacitor to explain this concept. If you consider this capacitor, if I apply current I here, how much amount of current I'll get here on the other side? Bhaskar, how much amount of current I'll get on the other side? It is also I. The question Maxwell was asking us is, capacitor is an open circuit. Then how current is flowing in between this? The explanation Maxwell has given is, current at any point is conduction current and displacement current. In this conductor, displacement current is 0. Whereas between this plate there is free space. And the current flowing here in this free space is the displacement current, ID. Here conduction current is 0. That's why at this point also you get same I. Got this dear? So current in free space or current between the plates of the capacitor, both are one and the same, which is displacement current. Is that clear, Bhaskar? So when you add these two Maxwell equations, you get a wave equation called as Helmholtz equation, which will tell you the behavior of a wave. And the wave you are getting here is called a TEM wave. And the wave you get here is a TEM wave. Now you tell me, is that clear, everyone? Okay, what we'll do is, a session at 9 p.m. today. We'll continue from this point, 9 p.m. session. What is a TEM wave? What are the characteristics of a TEM wave? How to draw the mathematical equation for that? And how this wave propagates in free space. We'll continue the concept from that particular point in the 9 p.m. class. So far, is it clear, everyone? Inform all your friends. The class will be from 9 p.m. Today 9 p.m. Okay. Unacademy offers 2 paid courses, 2 paid platforms. One is Plus subscription, other is Iconic subscription. Plus subscription, you got to have the face time of legendary faculties in the form of live classes, a weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll get all these features of a Plus subscription. Along with that, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators, preparatory study material, personalized test analysis, study booster sessions, and a customized study planner. All this in Iconic subscription. You're going for a Plus subscription or an Iconic subscription, go for a no-cost EMI, where total cost will be divided by number of months. Very much useful for students. Your total cost is divided by number of months. Affordable for a student. We are not charging anything extra. Moreover, you can use my code GCR10 to avail extra 10% off, both on Plus and Iconic subscriptions. If you're going for Iconic subscription, you get a personal coach. It means that you get a 1:1 live mentoring, increasing your chances of topping the exam. Moreover, you can use my code to get an extra 10% off. And in this complete January, we're conducting All India mock test for GATE 2022. This is the best platform for you to check your preparation level. Each Sunday, every Sunday you'll have this. And enrollment is free. You can enroll immediately after this class. You can use my code GCR10 and enroll and check your level of preparation. This is the best chance here. Each Sunday we are doing so. Special classes includes interactive live classes, poll for the learners, raise the hand option. You never miss a class when the notification is on. You can download the lecture notes once the class is done, and you can access anytime and anywhere. And we have introduced Unacademy Ask It Out, very important feature where you can ask unlimited number of doubts and get the solution in your preferred language. Very, very easy to upload your doubt also. So we are here to clear your doubts also. Please do not wander here and there to clear your doubts. These are the new batches. Where GATE 2024 for ECE will start from 27th of January. Ascend GATE 2024 for electrical. Ascend GATE 2024 for ECE. Spark GATE 2023 for electrical. Spark GATE 2023 for ECE. Evolve GATE 2023 for ECE. Evolve GATE 2023 for electrical. And these are the new batches across all the other branches. Each one of them will start on 27th of January. For any of the course, you can recommend your friends, you can recommend your known people, those are preparing. Each one of them can join using my code GCR10 where you get an extra 10% off. So do not wait, do not delay for your preparation. Join with the India's best faculty at Unacademy to score best and to be the best. Thank you all, dear. Thank you all from Unacademy. Thank you all from GATE Conqueror channel for joining us. Ask everyone to join us at 9 p.m. today to extend our deep discussion on electromagnetic wave propagation. Till then, have a good time. Thank you all.